Eso, pero es.
Hi, my name is Jurrego and this is my household bleach neutralization project. The first question asks you to prepare a 250 milliliter solution of NaOH with a 2 mol with a 2 molarity. In order to do this, you must use the formula M1 times V1 equals M2 times V2. For the values that you're going to use to replace in the equation, you're going to use the original stock solution found in the homework, which says that there is an NaOH solution that has a 4 molar molarity. So in M1, you replace the mass for 4 molar, and the volume is the variable you're going to find. In the second part of the equation, you replace M2 by 2M and 250 and the V2 with 250 milliliters. After this, you proceed to solve for V. So you multiply 2M times 250, which will give you 500, and then divide 500 by 4, and you will find that the volume needed to answer the question is 125 milliliters of NaOH. And since you need 125 milliliters of NaOH, you then know that then you will also need 125 milliliters of H2O. Then the second question asks you, what volume do you need from the stock acid solution to neutralize the homework quiz solution? In this case, it's 3B, which has an NaOH solution with a 2 normal with a 1 molarity and it's 250 milliliters. So you go back and use the stock acid solution from the homework that has a 6 molar molarity. So you multiply times 2 since it's H2SO4. So you need to use the little value next to the H. So you need to multiply the 2 times 6, and that will give you 12, and that's how you find the normality. So you use 12 normal, and then in NaOH, since it has a 2 molarity, you will use, and when it has no little values, then you will use the same molarity as the normality, so it's 2 normal. Then you go and use the same equation you used in the first question and replace for the values. So 12 normal is M1, 2 normal is M2, and V1 is the value you're trying to find, and 250 milliliters is V2, which will ultimately, as you solve for V, give you the answer that V is equal to 41.6 milliliters. The third question asks you for the microscopic view of the original base. So the first thing you need to know is how many moles of the NaOH are present in the solution. For this, you use the information previously given, which is the molarity of NaOH and its volume of 250 milliliters or 0.25 liters. When you solve for moles, you will find that there are 0.5 moles of NaOH present. And then you have to apply the proper ratio of each element, which is Na and then OH, according to its proportions, and decipher and or look and see how many moles there is present in each. Since they don't have any since there is one of each element present in NaOH, then you don't have to multiply times any other number. So you know directly that there are 0.5 moles of Na and there are 0.5 moles of OH present. Then you use the molecular formula of each of the elements to find how many grams are present of each of the elements. So zero point 0.5 moles of Na, and its molecular and its AMU, it's 23. So you multiply times it and you get 11.5. You do the same with oxygen and receive 16 grams. We're converting moles to grams. And then you do the same with H and you get 5 grams. 0.5 grams. Then you must add all of these values to figure out how many grams you have of NaOH, and you will find that 11.5 plus 16 plus 0.5 will give you 28 grams of NaOH. So you then know that you need to multiply this times the number of moles that were present in the NaOH. So you multiply 28 grams times 25 and you know for a fact that there are 14 grams of NaOH present. After you know how many grams are present, you know the mass, and you can use the density of the solute NaOH to find the volume present. Since NaOH doesn't share water's property of having the same mass and volume. So you replace in the D equals m divided by v equation, which gives you density. You replace for each of the values. So you put 2.13, which is the density of NaOH. You put 14 grams and you leave v as the variable you're trying to find. And after you solve for v, you will find that there are 6.5 milliliters of NaOH. So then you understand that of the 250 milliliters that you had initially, only 6.5 were of NaOH. Then you subtract the 6.5 milliliters from the 250 milliliters, and you will find that the result is the mass of water. And now, as I said before, you need to remember the water special property that its mass equals its volume. So since there are 243.5 milliliters of water, there are also 243.5 grams of water. And then what you must do is that you take this number of grams and convert it into moles, which will then lead you to the value of 13.5 moles of H2O present in the solution. So to find the ratio, what you must do is that you divide by the smallest number. Recall that there are 0.5 moles of Na, 0.5 moles of OH, and 13.5 moles of H2O. 0.5 being the smallest number, you divide all of the values by 0.5 and find that the ratio is 1:1 to 27, since 0.5 fits 27 times in 13.5. This is the actual microscopic view of the original base. All of the blue circles, as said there, represent one molecule of H2O. The red represents Na, and the purple represents OH. In this case, OH would act as a Brownstedt base because it receives H's. And Na NNA also has the same proportion as OH in the microscopic view, so the ratio is 1:1 to 27, as you can see. Also, the molecules are aligned, so the positive ends the positive and the negative ends of the water molecules are attracted and the positive sides of the water molecules are not attracted to the Na, the same as in the OH. So that is why the electrons of the water molecules near those molecules are shown. Then you proceed to doing the same calculations for the microscopic view of the original acid. So you start by figuring out the number of moles you have of H2SO4. Since you have one molar molarity, 0.5 liters or 500 milliliters, you solve for the number of moles and find that there are 2 moles of H2SO4 present. Then you use its molecular formula values to convert the 2 moles of H2SO4 into grams. So you do the procedure, and as you can see, there are 2 H2s. So then 2 times 2 would give you 4, and you find that you have 4 grams of H2. Then you do the same with SO4. Since there are 2 SO4 molecules and each SO4 molecule has 96 grams, you have 192 grams. And after you add the other 4 grams, you will in total have 196 grams of H2SO4 present in the 500 milliliter solution. But as in the same way before, you have to find its volume. So what you do is that you use the same density formula. The density of H2SO4 is 1.8 grams per milliliters. So you insert the number of grams, which is 196, and you solve for V, which will ultimately lead you to the volume of 108.8 milliliters of H2SO4. After this, you subtract the 108.8 milliliters of acid from the 500 milliliters of the whole solution and find that there are 391.2 milliliters of water. And finally, to find the ratios, you have to convert the 391.2 grams of water into moles, which will ultimately leave you with 21.7 moles, or rounded to 22. Then you divide by the smallest number, which is 2, and find that the ratio is 2 to 1 to 11. And now you proceed to the microscopic view of the original acid. Here you can see the ratio and the Brownstein acids and bases labeled. The microscopic view of strong acid in the solutions would look like this. Here, the green circles represent the acid H2SO4, and the blue squares represent the base NaOH. This basically represents the microscopic view of strong acid solution because the acid completely dissolves and the molecules are no longer together. On the other hand, this is the microscopic view of a weak acid in the solution. All of the molecules are together and there are the same number of NaOHs to the same number as there are of H2SO4. This is the graph that shows the concentration of H3O, A, and HA when strong and weak acids are put into the solution. So as you can see, the concentration of H3O increases the same with H2SO, the same as SO4s, but H2SO4 decreases as time passes. Finally, you have to find the percent composition of the acid, the specific mass of water, and the specific mass of acid from the original solution. We already had these numbers, but it's important to recall them. So know that the specific mass of water is of 391.2 grams, and the specific mass of the acid is of 108.8 grams. To find the percent composition of acid, you put the total number of grams on the bottom, which is 500 grams, and then you put 108.8 grams at the top,